So I have followed this ADS Dynamic Link Getting Started tutorial and completed ADS simulation. I set up Cadence Virtuoso and I set up ADS. I copied the Dynamic Link Examples directory over. I changed directory to the Examples directory. I set up Cadence setup files, started Cadence Virtuoso, and completed all the steps, creating Dynamic Link instance, bringing over design variables, and adding Cadence model files. Now, let's look at this Dynamic Link component. The name is Cadence Library underline cell underline view. The symbol is a copy. The schematic view contains pin names and IDF symbol instance. The IDF symbol component has Cadence library cell and view name, a netlist file of Cadence schematic design, and a freeze parameter with a default value of false, which means that Dynamic Link will try to get a new netlist from Cadence side. So once a netlist is successfully created, you can change freeze parameter to true and use it in ADS standalone without going through Cadence Virtuoso and Dynamic Link. This is one way to simulate Cadence design in ADS on Windows. You can select this set instance freeze mode to true. And now you can push down and the freeze mode is set to true. Now that you understand Dynamic Link component, you will be able to fix many Dynamic Link errors. In fact, you can run ADS simulation with a Cadence design without using Dynamic Link. If Dynamic Link failed to duplicate Cadence symbol, you can simply copy the Cadence symbol directory over to the Dynamic Link cell directory under ADS workspace from the file system. If Dynamic Link failed to generate netlist, you can simply use the Cadence netlist. I will demonstrate how to do that. So I'm pushing back up to the top of the ADS schematic design. I'm opening Cadence symbol. You can see that this is the ADS symbol is just a copy of Cadence symbol, and that's the netlist of the Cadence schematic. Now I'm launching Cadence ADE in order to create Spectre netlist file of the Cadence schematic cell view. Simulate netlist, simulation netlist create, and I'm saving this Spectre netlist file under my ADS workspace directory. I will give it a name, my PA.scs, and click Save. Now I have the Cadence SpectraNetList file for this Cadence schematic design. I'm going to do the ADS workspace directory to check for the new file I have just saved from Cadence ADE. To replace the dynamic link component with a Cadence netlist, I have posted an article on Knowledge Center. Here, you can search for it. If you type replace dynamic link netlist, you should find it. The title is Replace Incorrect Dynamic Link Netlist with Spectre Input.scs. In the first picture, I'm showing that dynamic link is composed of three components: dynamic link instance, variables from Cadence side, and Spectre model files. It is equivalent to the Cadence input.scs wrapped inside of a subcircuit. On Cadence side, the schematic design is the top-level circuit, but it is always a subcircuit of an ADS schematic design after being brought over by dynamic link. Next picture, comparing a dynamic link netlist with a Cadence input.scs file. The main difference is that Cadence top-level circuit became a subcircuit in ADS. The third picture shows how to replace a dynamic link netlist with a Spectre input.scs. Some of the information is out of date. The first step is no longer necessary. It caused ADS error when I posted this solution, but later ADS releases fixed the issue and no longer require global statement to be on the first line of the netlist. And step 2, if you have uninitialized parameters in input.scs, you do need to initialize them properly for ADS. And the bottom again shows that a Cadence top-level circuit will be a subcircuit in ADS. Now I will apply these steps. I have a Spectre netlist file. I will use it to create a pseudo dynamic link component. I will call it this cell, my PA, create schematic. I'm creating a schematic view. As we saw earlier in the dynamic link component, it needs the list of ports. I will look up Cadence CDF component description format in the simulation information section. The term order parameter contains the list of port names in order. So I will create the list of ports in the ADS schematic based on the term order parameter. The first pin is GND. second pin VCC1, then VCC2, and fourth pin is VIN, and the fifth and final pin is Vout. That's the port list. Now I need to add the IDF symbol instance. Let's look at the schematic created by Dynamic Link. Pushing down the IDF symbol, double click on it. You can see the library name is ADSRFlib library. Normally I enter component name here in the search field, but it didn't find IDF symbol. So I used the component library dialog to search for it. It found IDF symbol in the ADSRFlib library. I can simply drag this component from the component library dialog to the schematic where I want to place this IDF symbol. So this is freeze mode, so I'm not interacting with Cadence. I can use any name that is unique. And the netlist file is the one I have just saved from ADE. I called it my pa.scs. The freeze parameter is always true in this scenario. You can use either yes, no, or true, false. I'm done with the schematic view for this pseudo dynamic link component. Save this schematic. Now I need to create a symbol view. As I mentioned earlier, you can simply copy the symbol from Cadence side. I'm looking up Cadence CDS-lib file for the location of Cadence library in the file system. The library name is examples and its directory is examples, right under the examples directory. Under the examples directory, the power aim is the cell name of the dynamic link component. Under the cell directory is a symbol directory. I can simply copy this symbol directory over to the ADS side for the new component I'm creating. Now I'm looking up. Before I make the copy, I need to look up the directory for ADS library in ads-lib.dev file. The lib.dev file shows that the library name is examples_lib, and The directory is examples underline lib. And under the directory, my PA is the new cell I've just created. It has a schematic view for now. I'm copying Cadence symbol directory to the new ADS cell examples underline lib my underline PA. Checking my PA directory again. There is a symbol directory now. Now from ADS main window, there is a symbol view under PA cell. My PA cell. Opening the symbol, and you should see the same symbol as in Cadence Virtuoso. Now I'm done with creating this pseudo dynamic link component, and I'm ready to test it. I will duplicate the PowerM test bench and use it to test this new component. I need to copy the whole cell and call the new cell test my PA. I'm opening this new test bench. I will delete the dynamic link instance and replace it with an instance of this new component. I can simply drag this new cell from ADS main window to this schematic test bench. Dynamic link scales Cadence symbol by a factor of 2. You can modify the scale factor, but I have never seen anyone do it. That's why the blank area in the middle of the test bench is 4 times larger than the symbol. Both X and Y are magnified by 2. Once I'm done with all the connections, I'll save the design, and it's ready for simulation. Clicking the gear icon to run the simulation. After simulation, double check the result. Plotting S21. It looks way off. The correct result for PowerM example is on the right here, and the left side is from the new component. The reason of the wrong result is that port names in the schematic should match the connecting nodes in Cadence netlist, but it is all capital letters VCC1 and VCC2 in the schematic, while in netlist only the first letter is in uppercase. You need to watch for this type of mismatch. I created this dynamic link example to test such a case. Dynamic link would overwrite port names with its connecting named node. Since you do it manually here, you need to make sure symbol, schematic, and nodes in netlist match. You can modify symbol and schematic to match the netlist or edit the netlist. What I will do is to make a copy of the Cadence schematic to avoid changing the original design. I call it PA2. In this copy, so in this new copy, I will delete the label connected to a pin to avoid conflict. Deleting VCC1 and VCC2 labels. Do a check and save, and go to ADE to generate a new netlist. Launch ADEL. Simulation. Netlist create. And I will save this as my pa2.scs. You can see that VCC1 and VCC2 are all in uppercase now. I will save this my pa2.scs under the examples workspace. That should fix the issue of port name and node name mismatch. Double checking the content of my pa2.scs in VI editor. Again, both VCC1 and VCC2 are all in capital letters now. I will use this new netlist file in the schematic. So I'll use my pa2.scs, save the schematic, and pop back up to the top level and run a simulation again. This is the original correct result. Here I'm showing previous wrong result. After running simulation with the new mypa2.scs, the result is now correct. You can compare results from different data sets by clicking on a plot. In the datasets and equations dropdown, selecting a different dataset to compare with. Power MTest is the original dataset. Selecting S21, it will plot the original result and the result of this new component on the same chart. The results are identical, so those two curves overlap. This is test bench This is test bench for my PA cell, a new component, and this is the original test bench for the power amp cell. I could have run these simulations in ADS standalone, but I kept Cadence up because I wanted to generate Spectre netlist file from ADE. You typically don't need to do that, since most people usually run simulations in Spectre before trying to run ADS simulation with ADS designs. So Spectre input.scs should already exist under Spectre's simulation directory. Now I'm exiting ADS and will restart ADS standalone. And once ADS started, I will run the same simulation again. But before that, I will delete the dataset. And the standalone simulation should recreate the dataset. Click the gear icon to run the simulation, and the dataset is created under data directory. This concludes the demonstration of how to use a Cadence schematic design in an ADS simulation without using dynamic link. Thank you very much for watching.